Embracing the Green Initiative. Is it worth the cost to commercial building operators and industrial plant owners? Hello, my name is Allyn and welcome to our broadcast. Today we have a special guest who is an expert in green and sustainable building technology. He's an award winner of distinguished awards from the U.S. Green Building Council, ASHRAE, the Engineering Society of Detroit. He was mentioned in the Detroit Free Press and one of the Green Leader Awards. And because of all of his teaching in green and sustainable building technology, he's affectionately known in Detroit as the Dean of Green. Ladies and gentlemen, Mr. Jim Newman, welcome to our broadcast.
Thank you, Allyn. Always a pleasure to be here.
So nice having you here, Jim. You know, when in fact we're talking about green, I mean, there's so much information out there, energy audits, the politics, tax incentives. It gets pretty confusing. So I think the question is going green really worth it?
Well, we're talking about commercial and industrial buildings, Allyn, and actually, as we've talked about in the past, buildings use 40% of the natural resources and 70% of the electrical energy in the United States. So if we can conserve some of that energy, we're talking about a lot of energy and a lot of dollars.
Jim, in your teaching, you talk about green being a three-legged stool. I like that particular comparison. Would you talk about that?
Okay, that's actually called the triple bottom line. It's kind of the definition of sustainability. Some people use people, planet, and profit. Other people will say social, environmental, and economic. And I always say in many of the seminars that I've done all over the world, it's really good to be environmentally correct and do good things for the planet and do good things for people, but if you don't make a profit, you don't stick around very long, and then what good does all that do? Because you're not around anymore. So we look at all three. That's the three-legged stool. And it's called a three-legged stool because if you remove one leg of a three-legged stool, what happens?
Stool falls over.
That's right. That's right.
Jim, how does mechanical insulation fit into this puzzle of green total?
So relative to insulation, if you don't have good insulation on your ductwork and your pipe, you actually lose energy from the heat transfer through that ductwork or pipe, and you're losing that heating or that cooling energy, and it's a terrible waste.
Jim, recently you were involved in a huge project in the state of Georgia. What was it, an 11 million square foot Army base? Tell me basically, what did you find when you went there?
Okay, actually we were doing energy audits there, and again, energy audits are to determine where energy is being wasted. We had a 14-person team, actually. We had 3 PhDs on that team, one from Russia, one from the United States, and I forget where the third one was. Oh, from Germany. The third one was from Germany, actually. So, and we had a large team. And we were going around to the various buildings on this 11 million square foot Army base looking for where and how they could conserve energy. And one of the big things on a lot of these larger bases, and it's true in many campuses and in some cities actually, they have what's called the district heating and cooling system. District heating and cooling system, they have one large thermal energy plant that distributes the chilled water and the hot water or steam around this large, whatever it might be, campus, city, Army base, which I learned not to call a campus, by the way, very strongly. But what happens is, because you're distributing it for such long distances, you have to have, let's just talk about chilled water, for instance, where you're trying to cool these buildings. It might be 42 degrees Fahrenheit, leaving the chiller and being distributed out through miles of pipe. So it's very important to have this pipe well insulated. And what we find in most cases is that you've got 42 degree leaving water from the thermal energy plant, but by the time it gets to many of these buildings, it's over 50 degrees. We found buildings, we found barracks on this Army base, it was 60 degrees. Well, you don't do much cooling and you don't do any dehumidification with 60-degree water. And why was that? Which is probably what you were going to ask me,
I was
right?
going to ask you, what was the condition of the insulation on this project?
That's what I was going to talk about. The insulation was actually falling off the pipes. So what was happening, you had this 42-degree water, and in many cases, these pipes are in chases. They're not in the ground per se, but you build a chase so you can find the leaks easier and that sort of thing. So we're talking about Georgia, end of July. Temperature was 90 degrees, humidity to match almost. So you've got this 42-degree water flowing through these pipes and losing, or it doesn't lose, it's cooling, the heat actually comes in because heat transfers from warmer to colder. So the heat comes into the pipe, it warms up the water, and by the time it gets to many of these buildings, it's well over 50 degrees, which does not do a lot of cooling. So not only are you wasting energy, but the people aren't comfortable. And it's because of the poor insulation. It was basically a fiberglass type insulation, and it had fallen off over the years, and the pipe was bare pipe in many, many, many cases.
Jim, what would have been a better choice for the long run and the short run in that particular project?
Okay, well, we're looking at an insulation that doesn't transmit moisture because, again, you worry about corrosion. So if you've got water, moisture coming inside the insulation, which does happen on many of these types of insulations, then it's going to corrode the pipes too, and you see a lot of rusty pipes, and eventually you get leaks in those pipes. So you get less heat transfer because you've got the better cellular glass insulation, and it's also not going to fall off after a couple of years. These are the kinds of things we look at. These are the kinds of things that need to be done.
When we're talking about foam glass, cellular glass insulation, I wanted to get your opinion on the cradle-to-cradle nature of that particular product is what I'm thinking of as well. Would you talk about that?
Sure, excellent. One of the things we look at in LEED is what's called life cycle analysis. And that's from taking something out of the ground to making it into a product, to getting it to a job site, and then what happens when you deconstruct that building and what happens to everything inside the building? Well, cellular glass insulation is made from one of the most abundant materials on the Earth's surface, which is sand. As rocks get ground down and made into sand, and all the sand that's everywhere, it's very recyclable. It's there, I guess I don't know if I'd call it a renewable resource, for instance, like wind or the sun, but there's so much of it, and then afterwards, when you recycle it, you just use it again. We used to call it cradle to grave. Now we call it cradle to cradle. Use it again.
Good stuff. Well, Jim Newman, want to thank you so very much for joining our broadcast today and enlightening us on, some of the things about cellular glass insulation and why it is probably a better choice for longevity and basically getting the job done on so many of the projects that you're on, and we really appreciate your expertise on our broadcast.
Always a pleasure. Thank you.
Till next time, Allyn, Mark, goodbye, everybody.